Hello, everyone, and welcome back. Today we are starting into our final unit in science. We're going to be talking about space. So, how do we figure out things that are like way out there? We want to explore all of this stuff, but we can't actually go that far. How do we do that? That's kind of what we're going to be looking at in this unit. But before we do that, you learned a bunch of vocabulary words from grade 6. That was a while ago, so let's just go over them real quick. We live on Earth. Earth is a planet. It's pretty old. We don't know who named it. Planet means that you are a large body that goes around the sun in a predictable, repeatable pattern. So part of why Pluto got kicked out of the Planet Club is because it doesn't actually follow the same kind of orbit around the planet that all of these other 8 do. So we've kind of changed the definitions of what a planet actually is a few times, but essentially these 8 are your planets, and we'll talk about the other things differently. So a moon. Moons orbit planets. You can also call them satellites. So if you put like a GPS satellite or a weather satellite up into the sky and it orbits around the Earth, that is what a satellite is, but technically the moon is also a satellite because it goes around a planet. If we want to talk about the solar system, this includes our sun and everything in near vicinity. So it's our 8 planets. Pluto is going to get counted in this, all of the asteroids, meteoroids, comets, etc. Those last 3 might be a little confusing, so let's review them. Asteroids. These are like kind of bodies, I guess, in space that orbit around the sun, but they don't have that predictable pattern to be classified as a planet. They're also quite a bit smaller. So they could be like 1,000 kilometers wide, but they could also be just like a grain of sand, speck of dust, could be anywhere in between. So that's what we mean when we talk about asteroids. Think of like these big rocks just floating through space. When one of those big rocks that is floating through space decides it's going to come towards the Earth, well, space is just like a big empty pit of nothing. There's no air resistance or anything there. So things in space can get moving very quickly. When it gets close to Earth, Earth has an atmosphere. The atmosphere has gases in it, and those gases provide some air resistance to things that try to move through them. That's why your car gets better fuel efficiency if you drive at like 80 kilometers an hour versus 120. It's because of the air resistance. So if we have an asteroid that is going as fast as it can through space because there's no air resistance, and suddenly it comes into contact with air in the Earth's atmosphere, it's going to have a whole lot of resistance, it's going to make a lot of friction. That friction becomes heat, and that's why these things burn up when they get into the atmosphere. Contrary to that would be a comet, and these are basically just made up of ice and a little bit of dust. And if you get ice too close to the sun, it melts. And as the parts that are melting kind of trail behind, they make like that tail that you can see right there. So that was a quick review. Now we're into the Science 9 part. And so we want to talk about how do you actually explore this stuff? Because this is something that people have been fascinated with for as long as people have been able to look up at the stars. And we want to try to tell ourselves like some kind of story about like, this is so vast. What does all of this stuff actually mean? And what kind of information can we get from this? How can we use it? So that is how kind of astronomy got started in, I guess, the scientific realm. One big thing for like a practical use of looking up at the stars is telling time. Because back before people knew, okay, there's exactly 365 days in a year except for a leap year and there's blah, 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 blah. Like before people had cell phones and all this stuff to just know like, yeah, it's going to be cold in a few weeks. or it's going to be warm in a few weeks, depending on what season you're at, they looked at how high up in the sky does the sun get. My smartboard isn't working properly, so I can't actually draw on this picture here. But if you look at the middle, where the sun is right up at the top there, they would have some way of measuring that. And so that's what oftentimes like these Stonehenges were used for, is to be like, okay, how high up above the horizon is the sun? And the reason why you use stones is because they're relatively stable. They're not going to get bigger or smaller. They're not going to shift around a whole lot. So that point was constant. And what they did is they said, okay, the day when the sun is the highest up in the sky, we are going to call that the summer solstice. And the day when the sun is lowest in the sky, we are going to call that the winter solstice. And so they figured out, if we go back to this picture here, they figured out, and again, I can't draw, but imagine that the sun starts up at the top here. That's going to be probably your summer solstice. And then throughout the rest of June, July, August, the max height it's going to get is going to be progressively lower in the sky until you get to your winter solstice, December 21st, where it would be kind of behind that tree there. And so you see that like the sun is getting lower in the sky every day. And then after the winter solstice, it would start coming back up again. And that gave them an idea about what the seasons were doing. Next thing to note would be the equinox. And so what happens with an equinox is, like, you know how in winter we only get like 6 hours of daylight and we make you sit in a classroom for like 5.5 of them? But then in the summer, we get like 18 hours of daylight, and so it's hard to fall asleep at night because it's still bright out and you gotta like get blinds or something. The equinox is that halfway in the middle point. It's where you have exactly 12 hours of daylight and exactly 12 hours of nighttime. If we think back to this picture here, so if we said this sun in the middle is at our summer solstice and the winter solstice would be kind of behind that tree, your equinox would be halfway in between those two.